Simon Timms on Azure Functions.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Hello, I'm your host, Jeffrey Palermo. Welcome to the Azure DevOps Podcast. Our guest today is Simon Timms. He's a longtime freelance software engineer, multi-time Microsoft MVP co-host of ASP.NET Monsters on Channel 9, and also runs the Function Junction video channel on YouTube. Simon, hello. Welcome to the show, sir.
Hi, thanks for having me.
Yeah. We have a lot to talk about today, and today our topic is going to be on Azure Functions and running processes in Azure. But just for those not familiar with you, you've been in software a long time. What are the high points of your journey?
I don't know about a long time. I don't want to give the impression that I'm super old, even though I am super old.
We have 70, 80 years of experience now?
Yeah, basically. I mean, back when I started, we were still just coupling wires together and hoping the signals worked. I don't know. I've done a lot of stuff over the years. I'm really a generalist, so I've done everything from like writing device drivers for Android to writing distributed systems, web applications, DevOps. When I first came out of university, I was working for a company that developed some search software. They should remain nameless, but we produced our software on 26 different platforms. So I got a lot of experience on everything from HPUX to AIX to Solaris to ZOS. So I have done all sorts of things over the years.
Awesome. So the listeners of this podcast, and if you're just now joining us, this is your podcast for shipping software using the Microsoft platform. And if you fall into that bucket, if you're using Microsoft technologies and you're shipping software using it, then we talk about topics that are completely in that wheelhouse. Today, we're talking about running things that actually don't have a user interface and how to run that in Azure. And there's been a few different models. And if your software's still in the data center, it could be a Windows service or a scheduled EXE, or you could have processes that have for a long time run on SQL Server integration services or the old DTS packages. You know, all these offline jobs, and there's some different models for running them in Azure. And so we're going to go deeper into functions. But Simon, can you give the listeners just a rundown of what the options are for running backend jobs when you're targeting the Azure data center?
Sure. So there are a ton, of course. I have a talk that I do talking about how to host your application in Azure, and it's about an hour long going through all the options. But off the top of my head, there is kind of the old cloud services. So that was the original model that came out, 2008, I want to say, like when Azure first cropped up. And that is still a really good model. A lot of people still use that. A lot of the Azure services themselves are built on top of that. So including things like the Visual Studio Online, that's not the right name for it, but Azure DevOps runs on top of that still. Additionally, there's other stuff out there you can do. So there's app services that you can do kind of background tasks built into that as worker roles. Webjobs, worker roles is the original one. There's also stuff that you could do with Batch. There's Data Factory if you're looking to move a lot of data around. There's a ton of options. And the one that I'm most interested in at the moment is Functions.
So there's Functions. You've written some articles, and you do your Function Junction video channel on YouTube. How is Functions different from Webjobs?
So it actually runs on top of app services, which is the same that you would see for Webjobs. But the difference comes down to the hosting model. So there's two different ways of hosting a functions application in Azure. The first way is kind of the traditional way that we always see, where you allocate some resources and you say, look, I want a medium-sized virtual machine and I want it to be able to run tasks in the background, and I'll take 2 of those, please. So that is kind of the traditional hosting model, and that's going to cost you X dollars a month. And you know what that's going to cost you every month because you just look at how many hours are on a month, you multiply that by your hourly cost. So that's still a totally legitimate way of running Azure Functions, and you can still do that, and it's still applicable in some environments. If you have extra long running tasks, you can build them out like that. If you already have an app services plan out there that you're using for something else and you want to just couple some functions on top of it and don't want to pay anything more per month, then that's definitely a route that you can take. The more interesting model in my mind is the consumption-based model. So in the consumption-based model, you are billed by basically function execution. The actual unit that they use is a gigabyte second, which is a sort of funny SI unit, but it's basically you're getting billed for the amount of memory that your function is using and how long it runs. So if you have 50,000 invocations of your function per month, you're going to be charged 50,000 times however long it runs, times however many gigabytes it works out to. So the flip side of that is that if your function only runs once a month, then you're going to be billed almost nothing. And in fact, the default model for functions is that you get something like, I don't know if it's 10,000 or 100,000 invocations every month for free. So a lot of times you can build out a functions application or build out something in functions, and the cost to you is going to be 0 because it falls under that cap of minimum usage before you start to get billed for it. So you can scale down really nicely with functions, but you can also scale up really nicely with functions. So if you have a model where you need to be able to serve 1 million requests or 10 million requests over some time period, then functions will watch the incoming requests and it will scale itself out in the background so that it's capable of handling that number of invocations. And it will, of course, only bill you for the number of invocations that you hit. So that is, to me, a really nice way of running sites cheaply and effectively. And in fact, if you go look at some of Troy Hunt's blogs, so Troy runs a couple of websites, but probably he's best known for Have I Been Pwned, I guess. So he runs that entirely on Azure Functions, and he's very open about his billing, so he has some really good examples of how much he bills. And this website gets millions and millions of hits every month. And his bill for this website is sort of around like the $30 a month mark. So he's very efficient with being able to use this. And a lot of that is Cloudflare, but a lot of it is also that functions are so cheap to run.
So how would you make the decision of whether to run your, at this point, web application or website using Azure Web Apps with the app service plan versus Azure Functions with the consumption model?
So some of it is going to be a comfort thing. If you're used to building out, say, MVC-based backends or Web API-based backends, then you can still go ahead and do that for sure and write it in an app services plan. Functions I like because it has that ability to scale up and down. It's just one less thing that you have to worry about. Like, you don't have to worry about how big should I set this website to? Like, what's the sweet spot where I'm still making profit every month, but I'm also costing as little as possible. People are still happy with the performance of the site. So that to me is kind of the spot there, that if you don't want to worry too much about it, if you don't want to spend time tuning this, then Functions is probably a great place for you. And Functions, we talk a little bit about how you can use it for web applications. So there's a bunch of different ways to trigger a function. One of those is that you can trigger it off of an HTTP call. So then it starts looking like just your standard web application. So you can build a bunch of API calls or even calls that return HTML built out on Functions, and it will scale nicely and all that stuff. And it's triggered via HTTP. But there's a ton of other ways of triggering functions as well. So you can do things like you can trigger a function off of writing to blob storage. So if you write, say you have a website where you're uploading images or something like that, as soon as that image is uploaded to blob storage, then you can trigger off a function call to go and do some action with that. And that's kind of just built into functions. Also, you can do like queue messages and service bus messages, and there's about 8 or 9 sort of built-in triggers that you can use for functions. And then at the same time, there's sort of like a flip side to that, which are outputs that you can do with functions. So it's really easy to tie into writing a message or writing something back to storage or doing something that's tightly integrated into the Azure environment.
If I'm a listener to this podcast, I got to say, I'm just really confused because you have something called Azure Functions, which sounds like this. I mean, well, shoot, sounds like a method call. Or a JavaScript function, or any of the languages where you can do structured programming, and it sounds small. But now we're talking about running a complete web application inside of a single Azure function. Then it's not Azure Functions.
Well, you wouldn't really be running it inside of a single Azure function. So you would still have your function. So the function is the smallest unit you would get inside of Azure Functions. And typically, if you're thinking about that from a web API surface area standpoint, then that would be like your one method call inside of an MVC controller. So your get or your post or your delete or whatever verb you're going to do.
You have this full web application. You want to run on Azure Functions because you want a consumption model. You're saying you're going to have this whole slew of deployed functions that are independently executing and sort of stitching together a website?
Yeah, that's basically the way it looks like. But when you set this stuff up inside of Visual Studio, if you're going to build a new functions application, then you can set it up so that all of this stuff gets deployed as a unit all together. So even though you have, 500 functions or 30 functions or something inside of your system, when you deploy it, it gets deployed as a unit, and you would never kind of notice the difference between the way that gets deployed and the way that an app services and website would get deployed. If you go into the portal and you take a look at your functions, you can still see this list of 100 functions. But for the most part, you don't have to worry about that. You never have to go in and look at that. So it's not a big deal.
Okay, so you have one deployment, and then it's essentially the equivalent of a route or a URL might be the one-to-one mapping for how many functions are actually configured on the application or what you happened to have deployed.
Yeah, that's right. So I think a route is a really good way of thinking about it, that if you have 50 routes, you're going to have 50 functions.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
Okay, so that's one thing you can do with functions to use the HTTP side. Now, what about all these things that people have traditionally had running as Windows services or the scheduled task? Wake up at 2 a.m. and do something, and it takes 15 minutes, and then it goes to sleep until the next day at 2 a.m.
Right.
Are those good fits for functions as well?
They can be. Some of them. So one of the limitations around functions, at least for the consumption model of hosting functions, is there is a time limit to how long a function can run before it times out. So by default, that's 5 minutes. You can turn it up to as long as 10 minutes if you want. But ideally, you want to make these function calls sort of as short as possible, because that's what you're getting billed for. So if you're sitting around and waiting for stuff to happen, that might not be the best place to use a function. You can, of course, put it in like a full app services plan, and you can have it run for as long as you want. But if you have a function that takes a long time to run, there is a framework which is starting to be pushed by Microsoft pretty hard, and it is a great framework called Durable Functions. So this is built on top of Azure Functions, but it provides a way of running these long-running tasks in a way that isn't going to cost you a lot of money and is going to fit in with functions a little bit better. So basically what it'll be is, if you have something that takes 10 minutes to run, then you want to take a look at what that task is and see if you can divide it up. And there's two ways to think about dividing it up. You can either divide it up into phases. So, you do go and get all the data from a website, and then you process it, and then you save it. So now you've got 3 phases there, and you can set each one of those up as a function call and chain them together so that the first one will run, and you've got your 10-minute timeout on that. And then the second one will take that data and do some processing on it, and you've got 10 minutes there. And the third one will do some other things. So altogether, you have 3 steps, and that gives you sort of 30 minutes to spread your task out. The other approach to doing it is to fan out. So if you have something that you need to do in parallel, like traditionally, if you had something that you needed to do that was computationally intense or database intense or something like that intense that you usually run in serial on a single machine, Azure Functions makes it really easy to parallelize that and run it on 10 machines or 100 machines or however many machines the scaling puts you on. And Durable Functions has a great model for being able to scale that stuff out and then at the end gather it back together and come up with a single solution.
Now, is Durable Functions ready for prime time? Should people be adopting it if they have these 2 a.m. jobs that say, hey, it's been running for an hour at 2 a.m. once a day for the last several years? Is it ready to go for migrating to Durable Functions?
I mean, I don't want to push people to be like, you have to adopt Durable Functions over whatever it is that you're using right now.
Well, the alternatives, I guess you could try to jam it into a web job, or you could run it on a VM in Azure. What are the other options for those big 2 a.m. jobs?
So you could process it using Batch as well, depending on what your job looks like. You can hand that off to Azure Batch, which is a fantastic and I feel underused service on Azure. So that can be very cheap to run, especially because you can set up Azure Batch to run on low priority machines. But yeah, Durable Functions are a great solution for that too. Scheduler is kind of built right into Azure Functions. So that's one of the triggers that you can set up. So it's very easy to set up, even from a code point of view, to say like 2 a.m., please kick this function off. Or what I've been doing a little bit lately, allowing people to kind of configure their own scheduling on jobs is to push it into a Logics app and have the Logic app start up and do something at a time. But it also allows users to kind of kick that off whenever they want. And that puts a message on a queue and that triggers my function behind the scenes. So I think that's a pretty good model to follow too.
Okay. Now there's a whole nother class of offline jobs that are typically run as Windows services when they're run on a full server. And those are the service-oriented architecture or queue-based, the big in-service bus systems or mass transit systems where you got these Windows services and they're all listening for queues. And they're always running, but they're listening for messages and queues and processing. So how do those translate over into Azure?
So queue-based stuff is fantastic for Azure Functions. You can just park a queue in front of whatever function that you have. And again, this is easily set up within code. You can just say like this function here is triggered on anytime there's a message on this particular queue here. And Functions will pick up those messages. It handles all the polling and all the figuring out when there are messages. It'll also handle all the, oh my goodness, we've got 50,000 messages in the queue. We need to spin up 100 more instances of this. So that just happens transparently behind the scenes. And if you are coming from an end service bus background, you can think of each function as sort of being a handler, and then Durable Functions provide what end service bus would call a saga, that provide that sort of same functionality. Slightly different programming paradigm, but if you're familiar with sagas, then I don't think Durable Functions will be a big stretch for you.
Okay, so when it's running in a Windows service, there are some things like memory caches that have been normal, where it's a single running process. And let's throw out the high scale situation for the moment. You have a single Windows service, and it just processes the queues, first in, first out, however fast it can go. So do we still have a constantly running process when it's function backed, or is it stopping, starting, and not making use of any shared state? How does that internal model work?
So it's kind of like a mixed bag there. if you have a low throughput sort of service, it's very likely that your messages are going to go to the same instance of Azure Functions each time. So if you need to establish a cache, you can build up an in-memory cache, and that will probably be around for the next invocation of your function. It's not guaranteed to be around, so you need to make sure that you have the code in place to repopulate that cache if it does happen to go away. And the reasons that it might go away are just that there's some sort of a scaling event, and either you're on a new machine that hasn't had any process run before, or the machine that you were on has disappeared. You've been shifted somewhere else in the data center. So as long as you have the ability to kind of rebuild your cache, you're fine. And you can still go ahead and use a cache, but just know that it's not guaranteed to be there, because that machine might have restarted. You might be on a different machine from previous invocations.
Okay. So if you can refactor a few things, then the regular Azure functions are a good option. But if you can't refactor, you just need that. It sounds like just pushing it over to durable functions would preserve more of the assumptions made when Windows services are in play.
That's probably not a bad way of thinking about it. You can set up a cache in a durable function. And I suppose you could set up a cache in a way that it would be preserved the next time you came into that durable function. The only hesitation that I would have there is that durable functions, when you invoke them, and you have some sort of a workflow defined inside the durable function, the way that the state of the function is reinflated is it uses event sourcing to do that. So if you have a durable function which goes off, gets a bunch of data, and then does some processing on that data, and you just have that data kind of stored inside the durable function, then it's going to get persisted out to table storage. And then when your function reaches another trigger point, so like when it's done or a timer is hit or something happens, then it's going to reinflate that state. So if your state is really, really big, it's going to take a long time to kind of reinflate that state. So that's just something to keep in mind. So I go into some more detail about this stuff on Function Junction. So if you're interested in really getting to the nitty gritty of like how durable functions work, we have some videos for that. Okay.
You had mentioned orchestration, and regardless of how listeners may have it implemented now, if you're doing a PayPal transaction and then integrating with the two other systems, it may take some time. And if one of those second systems is down or has a maintenance window, you may be waiting for it to come back up, and you have a long running business transaction. It's not that you need the program running for that 1 to 2 hours, but there's something where the transaction just has to wait on something external in order to be finished. So how do those long running business transactions look with durable functions?
So that's a great example of something that you can play around with durable functions on. So the idea behind durable functions is that this stuff is going to kind of come and go throughout the lifetime of the function. So if I have some sort of long-running business process where I need to call out to a service, and maybe that service is down, what I can do is I can set up some redundancy inside of the durable function. And this is a great place to use durable functions, is I can say, as soon as you start off, go and request something from this API. Oh, the API is down. Okay, well, what I want you to do is just wait a little while and try again. And when it's waiting, the durable function, it's no cost to you if it's not actually running. So what you can say is, execute this function with a retry. And you can tune the parameters around that retry. You can tune how long it's going to wait between retries, and you can tune how many times it will try. So if you have an unreliable API on the other end, you can say, please go and get this data from the API, retry it 10 times and wait 30 seconds between each retry. So then it will go and will try and do that. And as soon as it finds a successful time, then the durable function will kind of move on to the next step in the function. So if you need to coordinate a bunch of API calls to unreliable APIs, then all you need to do is just set up some retry logic inside of the durable function, and it will go off and retry this however many times that you need, and hopefully it will manage to get through that. You can also set up timeouts inside of durable functions. So these are the same sorts of timeouts that you'd see in Service Bus, and you can say, like, please go and retry this function or this call as many times as you can, and for a maximum of 10 minutes. And then when 10 minutes hits, we're going to give up and we're going to do something else. We'll do some sort of compensating logic that will take us down a different code path. And you can set all of that up inside of a kind of a workflow inside of the durable function.
Okay. So there's a whole lot of logic going on here. There's got to be a way to test it all locally. And I don't have my own data center locally. So what does that testing environment and process look like on a dev workstation?
I'm outraged that you don't have your own data center. That seems like an oversight. Well, durable functions, they're just function calls inside of some C# code or some F# code or JavaScript code. So you can basically test them in the way that you would normally test code. And you can put in some function calls in there and just unit test it and make sure that your logic flow looks right inside of the application. So standard unit testing frameworks should be just fine for that. Okay,
now what about the corollary to full system tests, where you have, let's say you have 2 and 3 functions chained together, or you have that retry or the waiting for another API to come back online. That's a lot of logic and a lot of places that things could go wrong. How are those things tested?
So you can test those kind of largely with unit tests. If you feel the need to do some like running tests and simulate stuff going wrong, the Azure Functions API or the Azure Functions runtime does work on your local machine. So if you're running Visual Studio or anything else and you hit that F5 to run your function locally, that's actually using the same runtime that is used up in the cloud. So you can have some faith that if it works locally and you can test against it locally, then it's going to run sort of the same way in the cloud. I think there might be a couple of like really minor caveats around some of the triggers on that stuff, but for the most part, it is pin compatible with what you're going to get in the cloud.
Awesome. Okay. So we've talked about the hosting model for functions and orchestration capabilities with durable functions and the various triggers, and that there's not a whole new testing story. It's just the regular testing that you're used to. Are there any other scenarios or application types that we haven't talked about that are good targets for Azure Functions?
There's a lot of different stuff that you can do in Azure Functions. Of course, you can build out an entire API on Azure Functions. If you're looking to build a serverless application as a whole, so like a website that is serverless, then Azure Functions is a integral part of that. So you can build your Azure Functions and you can protect your Azure Functions with JWT tokens, which you can get from like Azure Active Directory B2C. So you can put your Angular app or your Vue app or React app or whatever it is up in something like just blob storage, front that with a CDN so that you can get SSL termination and load balancing and all of that. And then on the back end, you can have Azure Functions. So it would allow you to log into your application using Azure Active Directory. That would put a token on people's browsers and they can use that to authenticate against the Azure Functions. So that's a really nice application of Azure Functions. Backgrounding tasks is really another great place to use it. If you have an application that user clicks a button and then it sends an email, by using Azure Functions, you can just kind of background that email sending. So you can immediately respond to the user, and the stuff that doesn't have to be done right away, you can shove into a queue and an Azure Function can pick it up sometime later. And that provides some reliability guarantees as well, that if something's wrong with your email provider, then that message is just returned to the queue and it's retried at a later date. So those are two really good applications.
Okay.
It's probably easier to talk about like places where Azure Functions are not really good. And those would be things like there is a limited set of languages which are supported in Azure Functions at the moment. So if you're writing code in something like Go, that isn't supported yet inside Azure Functions. And these are all things that are being worked on internally in Microsoft. But something like Go, you couldn't do right now on Azure Functions. If you have stuff that is like really long running and is a single process, so the thing that comes to mind right away is something like training a model, a learning model. That's probably not a great application for Azure Functions because you're going to be running for a really long time. And although it's possible to parallelize building neural nets, it's kind of tricky, and it's easier to just sort of do that in series on a VM or something else like that. And then by all means, you can load that model into Azure Functions and use it, but the initial building of it is probably not ideal for Azure Functions. And then anything that is going to interact with something that's actually on-premise is probably a little bit tricky to do with Azure Functions. You would end up building connectors and those sorts of things so that you could get messages back and forth. Like a service bus relay would probably work fine for that if you wanted to use functions for that. But yeah, like functions are probably my go-to at the moment. If I was building a new application right off the bat, I think that Azure Functions would tend to be where I would lean.
And because it's the same framework, the same libraries, are there any barriers to portability to going back and forth between hosting your job as a web job versus hosting it as an Azure function?
You would have to probably write your functions application in a way that would allow it to be a little bit more portable. So kind of defining the endpoints, the bits that are visible, differ between a web job and a functions application. So you could have a thin layer in there that was just responsible for receiving requests and then transforming them into some kind of standard interface, and then you could pass it off to your backend code that did whatever. So you could set up a model that would be portable between the two. I don't know, that falls in my mind into the space of like, well, what if we're going to change databases somewhere down the road? And like, it's something that people think about, but it's not something that people realistically do. Or if they do end up in those scenarios, then it's something that you can do at that time. Like because you can run Azure Functions under a consumption model or under an app services model, that level of portability takes away a lot of the need, I think, for being able to transition between like Webjobs and Azure Functions.
Sounds like it's a one-way migration for people, because Webjobs has been around for a long time before Azure Functions. If people have a lot of things already running as Webjobs, seems like it's easy to move it over to Functions, but if it's designed for Functions, it's not as easy if you were to go backwards.
I guess that probably depends on what it is that you're running. If it's something like a scheduled task, then the portability there is very good. If it's something that is like an HTTP trigger, the portability there is not as transparent, but you could still do it if you really wanted to.
Okay. Now, you briefly mentioned Azure Batch, and that doesn't get a lot of airtime. I don't hear a lot of people talking about Azure Batch, but what are the scenarios where you would actually go for Azure Batch instead of Functions?
Yeah, Azure Batch is a little bit more boring, and I'm sad about that. But so scenarios where Azure Batch
it has an awesome name.
Yeah, I know. It's super like, the most boring possible way that we could name this. So Azure Batch has been around for a while, but the idea behind Azure Batch is that you have some sort of a task that is easily parallelizable, and you want to run it on a bunch of machines, and you maybe want to run some custom code on those machines. So you can set it up if you need to run your Go code, or you need to do something like that across a bunch of machines. Then you can set it up using Azure Batch. You farm out all of these requests, and Azure Batch handles kind of the scheduling and the retry logic and all of that until your batch is completely processed. The one thing that I mentioned about it is that you can use these low priority VMs. So if you haven't heard of a low priority VM, it's pretty nifty. The idea is that in an Azure data center, there's maybe like 10,000 machines. And those machines are going to have busy times and they're going to have quiet times. So probably between sort of like 9 to 5 in the local area is going to be busier for those machines. And then after hours, those machines are not as heavily used. So you can actually get access to those machines at a discount. And the discount could be something like, I was looking at a virtual machine that by normal standards was going to cost 42.9 cents an hour to run this virtual machine. If you do low priority, then you can get that same virtual machine for about 10 cents an hour. but you can't control when you get it. And it's possible that if you have something running on it, it's going to be preempted. So Batch is really good for that scenario where I have 100,000 images that I need to do watermarking and resizing on. I can throw all of those into Azure Batch. They're going to get farmed out to all these low priority machines. It might run at midnight. It might run at 2 a.m., something like that. But it's going to get done in some length of time. It's not going to cost me much. And because I can be preempted. Like if I do get preempted on processing an image, it's not a big deal, right? Because maybe the processing of an image is going to take 30 seconds. At worst, you're throwing away 29 seconds of work and restarting that somewhere else. So that's a good scenario for doing something with Azure Batch.
Okay, so if there's a queue of messages and you have a lot of flexibility into the processing time, and I don't need that queue processed, within minutes of the message being placed, then I could essentially put the queue handler code in whatever form, deploy it to Azure Batch, and it'll run when it runs. And then I just have to tune it. If it's taking, a couple days, and maybe I need to pay a little bit more to have more priority. But if it works out, then it's really cheap.
Yeah. So that's a good way of doing it. So I have a friend who's really into blackjack. And he was doing some extensive calculations. Actually, I think it was poker. Now I'm thinking about it. So he was doing some extensive calculations, rebuilding probability tables out of poker hands. So he pushed that off into Azure Batch, and he ran for like 3 weeks doing these calculations. And it didn't cost him a whole heck of a lot because he was able to take advantage of these low priority VMs. And yes, it took him a lot longer than if he had run it under normal priority VMs, but the cost saving was probably 75-80%.
I wonder if there's some of these newer data centers around the world that have not gotten saturation or fully adopted, where there's just a whole lot of excess capacity in a particular region as well.
That is possible. I don't know that those statistics are published for kind of obvious reasons that we don't want people to know how busy our data centers are. But there were rumors a while ago that, I don't remember which data center it was. One of the Eastern European data centers, I think, was kind of like approaching capacity. And they were busily trying to expand it. So that if you were running kind of low priority VMs there, then there might be less of a chance that you would get your low priority VMs than if you chose a different data center to run them on.
Well, one of the first ones, you're probably not going to get a whole lot of excess capacity at US East.
It does seem like a popular data center for both AWS and Azure.
Right. Okay. Well, before we go, is there anything in particular that our listeners should follow up on? Obviously, Function Junction, but anything else that we should point them to?
Well, there are kind of the standard people to follow on Twitter. I can link some of those. So people who are really involved in the function scene, there's some really great blog posts that come out from people. Durable functions, I think, are definitely worth looking at. I feel like they've been out for about 18 months now. And they're becoming pretty stable. I think they're a good alternative to something like in-service bus. And of course, you don't have to pay the licensing cost on top of that. All of that is kind of rolled into the cost of whatever it costs you to run your functions. Overall functions to me are a cheap and really scalable way of running your applications in the cloud.
Awesome. Well, we'll definitely get those included in the show notes. And thank you so much, Simon, for visiting with me. This has been great.
Not at all. Thanks for having me.
And until next week, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.